let's check out the cases where we're looking backwards. So what if we're given the percentage of data that's either above or below a certain point, or even between 2 points, depending on how much info we're given. And we want to know what that data point or what those 2 data points are. So let's use Mr. G's class again. So we've got a mean of 75, standard deviation of 5. So I'll remind us mu and sigma. And so if we want to know 15% of students scored less than what value? So there's some value, we don't know what it is. There's some cutoff place where 15% is below that point. So we want to know, okay, what is that data point? Basically, what is that score? And so if we bring up Excel, we can use our norm.inv function. So this is the inverse norm, kind of working backwards from that norm distribution function. So the important thing is it gives the probability below some point. So we want norm.inv, so we can scroll down to that, hit tab if we want, or just type it all in. So we want the probability below, and we're going to want that probability as a decimal. So we're going to say 0.15. We want to know 15% of the data is below what? And our mean is 75, standard deviation is 5. And so that's all we have for this one. We don't need to say true, false. And this one's going to say 69.8178. Right? So if we're rounding to the nearest whole number, we could say 70. If we want to round to a couple decimal places, that's fine too. Maybe the score isn't all whole numbers, so we could say 69.8, let's say. So 69.8, right? So 15% of students scored less than 69.8 on this test. All right, in part B, if we want to say, well, 65% of students scored at least what? So 65% of students were above some value. So if I'm wondering visually, like, where do I place that? Remember, 50% is going to be where the mean is. So 50% above that, if I want even more, that means I have to go to the left here. So we want more than 50%. So we want 50% and then some scoring above whatever value this is. So we're going to figure out what is the score that makes this shaded area 65%. All right, so we're just working backwards again. So, all right, if we updated our inverse norm, if we said, well, from 0.15, let's make that 0.65, this would give us the score where 65% is below this point, right? So we go, well, I don't want 65% below. And there's not going to be a super easy fix in terms of doing 1 minus inside Excel. But what we can do is we can say, well, let's look at our visual here. This is, again, why the visuals can be so helpful and help avoid some of those simple issues. So if 65% scored at least or above some number, that means we know, well, okay, down here is 35%. And that's what we're going to want to use for our inverse norm. So let's just go back here and say, all right, I didn't actually want 65 because that's to the right or above. I wanted 35.35, which is to the left or below. And now we see that we get a score 73 let's say 73.1 if we're rounding to 1 decimal place. So 73.1. Again, our answer should make sense. Remember that the mean is 75, and based on our visual, we know we want something a little bit less than that. 73.1 is indeed less than that. So our visual, our result, all those things should kind of tie in together. Now in part C, we get something interesting going on. We want 25% of students scored between 75 and what? And so this one, we had to have one of those two scores. We couldn't have neither of them, and I'll kind of explain why in a minute. But let's start with our visual. So we know 75 is right here, right? That's our mean. And so we want 25% of students scored between that and what? And usually we list the lower bound first. So we assume the what is going to be higher than 75. So I don't know exactly where it's going to be. I'm just going to put a mark in here. I have no idea exactly what it'll be, but that's where Excel is going to help me out. So we're trying to figure out, okay, what is this score so that 25% is in there? Now, in order to use our inverse norm function in Excel, we'd want to say, well, it's going to give me everything below that question mark, right? So if I want to know all of this stuff, right, from that question mark to the left, then it's the 25% plus the 50% that's going to be below 75. So we would use 75% to figure out what that question mark is. So right, again, 50% is the red part, the 25% is the blue part. So in total, 75% is below what point? Now, we know that the value should be above 75. So if we don't get that, something is off. But let's just check. If I change this to a 0.75, so 75% of the data is below what point? We get 78.4. And let's make sure that kind of makes sense, right? 78.4. Well, is it above the mean? Yes, it is, right? And it's not even an entire standard deviation above. I was just kind of guessing that it would be maybe close to, but not quite a standard deviation above. But if your visual isn't quite correct on these little tick marks, that doesn't matter. It's really just the idea of understanding above versus below. And then the other piece is, why did we need to know one of the values but not the other one? Why is it okay to have one missing and one not? Well, the 25%, we had to be able to place that somewhere, right? We couldn't have been able to set up our visual without knowing that 50% was below this point. So we needed to have the initial value to kind of give us the remaining portion of the tail, what percentage is in the tail. Now I use the mean for simplicity. You didn't have to though. We could have said, 25% scored between 60 and what? And we would just have to use the inverse norm function for 60 and say, okay, well, what data point is, or what percent of the data is below 60, that kind of thing. So we could have done that again with some other point, 60 being back here somewhere. We could have said, okay, yeah, 25% is in here, and inverse norm would have told us what this part is, norm would have, the regular norm distribution would have told us the part in red, and then we could have combined that with our 25% and used inverse norm to figure out what our missing data point is. So again, between those two functions, if you are given a percentage, right, in these cases we're given a percentage, we're going to be using that inverse normal. If we're given just the data point, or data points, plural, then we're going to be using the norm.dist.